Question 16, I'm being asked to prove that two sides of an expression are equal. And to do this, I'm actually going to split it into two parts. I'm going to work with this, and then I'm going to work with the other side as well. And if I can turn them into an equal thing, I know they must be equal. So, how can I do this? Well, the first thing I'm going to do is expand out all of these brackets. I'm starting off with 2m plus 1 squared, and then going to subtract 2n minus 1 all squared. So first I'm thinking, well, this is the same as having 2m plus 1 as another bracket there. I would always recommend, when it comes to writing squares of brackets, just rewrite it as a second bracket. 2m times 2m is 4m. 2m times 1 is going to be 2m. 1 times 2m is going to be 2m. So we've got a total of 4m. 1 times 1 is then going to be 1. And that's going to be subtracted from 2n times 2n is 4n squared. Then we're going to have 2n times negative 1 and negative 1 times 2n, so minus 4n in total. And then negative 1 times negative 1 is going to be plus 1 just here. You'll note I've still put it into brackets. The reason I've done this is it helps us remember when we're subtracting here, the signs of that second bracket need to change. So I'm going to have 4m squared take away 4n squared plus 4m take away negative 4n, so plus 4m, and then I've got 1 take away 1, that's just going to be 0. So we've got this value just here. Now let's have a go at the other side. So we've got 4m plus n times m minus n plus 1. Well, first thing I'm going to spot them. I've got this 4m plus n, so it's going to be 4m plus 4n, m minus n plus 1. So now I can do 4m times n. I'm going to get 4m squared minus 4mn plus 4m. Next, I'm going to do 4mn. So 4n times m, that's positive, so plus 4mn plus 4n times negative n, so that's actually going to be take away 4n squared, and then plus 4n times positive 1, and we're going to get plus 4n. Finally, we can see we're getting close, very, very similar, but there is one difference. But for both negative 4mn and positive 4mn, we've got like terms, and they would cancel each other out, meaning we'll be left with 4m squared plus 4m minus 4n squared plus 4n, and we note that red is now the same as blue. Let's just write it in the same order we had, so 4m squared minus 4n squared plus 4m plus 4n. Does not necessarily have to be in the same order. I think it's just easier for us to show, and therefore they are equal. For part B, Sophia looks at this question and it says this shows that the difference of the squares of any two odd numbers must be a multiple of 4. Well, let's just check what she's saying here. First thing, I need to show that I've got two odd numbers here. An odd number is just anything that is not an even number, so we often do it by adding or subtracting 1 from an even number, which is a number times by 2. So those are odd numbers. When we square them, we subtract those, we're finding the difference of the squares. Just checking any two odd numbers, well, we've got 2m take away 2n. Because there's different variables, that means they are not tied to each other. They can be any number at all. So that is what she has looked at. We've got the difference of two squares of any odd numbers. Is it a multiple of 4? Well, to prove something is a multiple of 4, I have to prove that it's divisible by 4. And the way to do that is if I were to factorize out 4 from this equation, I'd be left with 4 lots of m squared minus n squared plus m plus n. And I can see, yes, that must be a multiple of 4. So, yes, because you can factorize out 4 from each side. So it must be sorry, a multiple of 4.